Okay, welcome to part two of this video. We're now looking down on the North Pole using the GFS data from midnight with the UK on the 0° meridian here, India in this region, China, North Pacific, US, just to orientate yourself. Fields that we're seeing are mid-latitude jet stream or jet stream strength in these blue and pink contours. How vertical velocity, or positive vertical velocity, are sent in the tropics, shown by these green, yellow, and eventually red to pink shadings. And these vectors, which are representing upper level outflow from convection, which basically show where there's irrotational wind, as we call it. So you can see at the present time, we've got our equatorial Rossby waves that I've highlighted all three of them. They're producing upper level outflow in the North Indian Ocean in this region here. And you can see some, although remote from the jet at the present time, across the maritime continent in association with the MJO. So the outflow in this region, you can see causes an acceleration, these pink shades of the jet, and an anticyclonic pattern portion of it coming across to the north of the Himalayas, which results in some downstream troughing across eastern China. So downstream troughing here means that geopotential heights are lower to the north, which means that we must have cold air here, and cold air making it to southern China versus the tropical water of the South China Sea means that we're going to develop a very, very strong thermal gradient, which is very good for promoting strong jet streams. So here are equatorial Rossby waves seen at 850 temperatures and winds just taken from GFS. And here's our cold surge tomorrow advancing across China, as I say, really strengthening that baroclinic gradient. So as that happens then, we start to see downstream of this trough that strong gradient resulting in an acceleration of the jet across the West Pacific. And it starts to have some interaction with the outflow of this equatorial Rossby wave, or potential, let's say, low risk of a tropical cyclone to the east of the Philippines. As that happens, and the warm air, I say the interaction of the outflow of that and the warm air forward of the trough gets drawn into the mid-latitude jet stream, you can see that you start to develop this huge upper level sort of outflow where the winds are all spreading apart, that further enhances this jet stream in the North Pacific. And this is where we really start to generate our equatorial Rossby wave packet. This is on the 19th to the 20th. By this point, you can see the size of this pales everything else that's going on in terms of the northern hemisphere into insignificance. This is the main feature, resulting in incredible acceleration of the jet, and the Rossby wave packet is born, and then we'll start to move on. So you can see that if I move this forwards in time, get to the end of this run here at the 20th, where our packet is very much in that, it sort of shows the more zonal pattern of the subtropical jet anyway in the eastern hemisphere versus this incredible meridionality or amplification running across western parts, already reaching parts of the US by the time we reach this point. So this is basically the model again. Equatorial Rossby wave packet is generated, increases the amplitude of these, and this is the mechanism you can see here. So we've got a zonal flow initially, tropical cyclone or some source of tropical convection with an outflow, produces a jet streak because it strengthens the thermal gradient. That produces a left exit region, which generates a downstream cyclone that produces a jet streak, that produces a downstream cyclone, etc. And you can see how we move through a zonal to a very meridional pattern. On the back of that initial amplification, then we get a surface cyclone. You can see here, this is on the 23rd, that produces cold air south again across eastern China into the northwest Pacific, resulting in a further sort of sharpening of the thermal gradient, which goes as the next sort of set acceleration of the jet, which will produce another equatorial Rossby wave packet. And you can see these two as they're basically generated. Here's number two as it appears around about the 19th, 20th and runs across to bring us the potential cyclonic wave break near Greenland, cold across the UK. And the third packet, there's several days later on the 23rd that's generated, runs, and in this run reinforces that block. So these are all the things we need to work out for that to happen. The orientation of the jet correct across Asia now, how does convection across the North Indian Ocean interacts with that, downstream trough that develops in the cold surge across eastern China, the South China Sea and Northwest Pacific, the interaction of outflow from the MJO convection and the equatorial Rossby wave, low risk of tropical cyclone near the Philippines with that, which generates as our equatorial Rossby wave packet. That's got to transfer east-northeastwards into the mid-latitudes, very complex. We've then got to get an anticyclonic wave break in the right spot, again, difficult to do, and that could potentially be reinforced or destroyed by the next packet in late November. So these are the variations in the runs you've seen. Yesterday's EC, which was where the extended run came from, which had this block, and you can see in there this building across Greenland with a trough and cooler air being pushed down across Europe. But one day later, just subtle changes mean that this block is now being signaled to be slightly further west. The cold air outbreak across the central Atlantic, which would result in extreme baroclinicity and potentially an unsettled or even perhaps stormy spell across the UK. These details have all yet to be ironed out. We don't even generate the packet for several days to come, but you can basically see the complexity of this situation and why it's not that predictable at this present time. I hope that helps. Take care. Goodbye.